Go. Hello and welcome back to Calculus 2, section 10.7, part 2. Root test. So we talked about ratio and I said extremely important, don't mess it up, learn it. Now we have root test, which is kind of in a close category. We have very specific problems that we are going to use the root test on. So root test. Thank you. So for the root test, we are going to look at the an raised to the nth power. Maybe I can put in parentheses and put the nth power there. Going from some number to infinity. It doesn't matter where it goes. And then the root test goes this way. You take the nth root of your absolute an to the n, which will give you just an. Then you take the limit of that an as n goes to infinity, and you are going to have the same three cases that you have for a ratio test. Your answer could be less than 1 for convergence, larger than 1 for divergence, or equal to 1 for inconclusive. Use something else. So this is the deal. So the conclusions are the same as in ratio test. Ratio and root test have limit less than 1, converges limit larger than 1, diverges limit equal to 1. Use something else. So now, how do you recognize root test? Well, you use your eyes to look at the problem. If it has the overall exponent of k or n or whatever it is, the nth root is going to kill it. Yay, right? If you have like number 13 over here, one is a square and the other one is k, that's not a root test because the kth root is not going to kill the square. So that's a ratio. Bueno? So, problem 17, a k and a square. That's not going to work. Problem 19, a k and 99. Ratio, because, right? 18, k squared. That's going to work because what's k squared in the exponent? It's k times k. So your kth root is going to kill one of these exponents and the other one stays. And then you do the limit with L'Hopital, right? Or what it is. I also said last time, if you see a factorial, which is the explanation point, right? You see a factorial is ratio. So you use ratio test 16, 20, right? 18 is a root because you have k squared. So let's take a look at first. Yes.
18 to the third is not because it's k squared.
Is 18 what?
Isn't that c1 plus something over k to the k? Isn't that e?
Yes.
So would that be e to the third or?
Yes. And what will we know that e to the third? Is that bigger or smaller than 1?
Well, I'm asking if it's k squared, so there's a square.
No, but one of those k's from k squared is going to be killed by the root, right? So that's our first example. So problem 18. Summation, yes sir, of 1 plus 3 over k raised to the k squared from 1 to infinity or whatever, 10 to infinity, doesn't matter. So here in orange, k squared is k times k. So if I know coughing takes, if I take kth root of 1 plus 3 over k, k times k over here, the root gets cancelled with one of these k's, and you get 1 plus 3 over k to the k. Now you take the limit as k goes to infinity of 1 plus 3 over k to the k. And for those of you who know the definition of e, this is immediately e cubed. Otherwise, you have to do L'Hopital rule with those ln both sides, and yes, so otherwise it's going to be a page of work to get it. The answer is hell yes. You'll memorize it by placing an r instead of 3 and placing an r over here. E to the r. That's the way you should learn this one. What do we know about e cubed? Definitely bigger than 1, meaning divergence by root test. And we're done. 2 lines, if you know what you're doing. 2 lines. So the first one is hit it with the nth root or kth root, whatever. So hit it with the nth root, and then whatever is underneath, just work it out in a limit. And the limit will tell you what you get. Slightly easier problem, 12. Summation of negative k over, of 2k over k plus 1 raised to the k from 1 to infinity. Now, I hope you remember those absolute values. You see the absolute values here?
Where?
Can't see him.
Right there.
I can.
So the absolute value is not there for decoration. So that absolute value is going to kill this negative sign. So now you have your kth root of absolute negative 2k over k plus 1. I did not put this absolute value earlier because it was positive, right? It was 1 plus 3 over k, so I didn't bother. But now there's a negative, and that's going to kill it. So now the kth root and the kth exponent cancel each other out, and then the absolute value is going to kill the negative. So we get 2k over k plus 1. Limit k goes to infinity of 2k over k plus 1 is equal to 2 larger than 1 diverge by root test. Diverge by root test. Done deal. I'm modifying this problem as 3 to the k divided by k to the k from 1 to infinity. Step number 1 is to do what? Do what? 3 over k. Yes, so combine it into 3 over k, everything raised to the k. Now, is this geometric? No, because geometric cannot have a variable inside R, right? So inside here you can have a fraction like 1/2, or you can have a 3, or you can have, right? But you can't have 3/k. So it's not geometric. So can you use rules for geometric? No, you can't. But luckily everything is raised to the k, so kth root 3/k to the k, and that's gonna kill the k, okay? And then 3/k, I gotta switch to n because limit k goes to infinity, 3/k is equal to 0, less than 1, converges by root test. Do we know what it converges to? No. What are the only two series where we can find the sum? Geometric and telescoping. Very good. Geometric and telescoping are the only ones, which is why those are the ones that you learn first in the same section. So 10.3, and if you look at the sheet I gave you, all the way to the right in the comments section, those are the only two that provide you with a sum. No others will provide you sum. Great. Is this enough of the root test? You want one more?
One more.
One more. All right, fine. '26th. Looking good. 26 looking good. 1 to infinity, 1/ln k plus 1. Everything raised to the k. You have 7 seconds. Go.
Convergence.
You can skip the square root part, or the k root part. You already know what you're going to do. No, for comparison, that's as well. No, you only got the comparison. You're not doing comparison. Get all that out.
And then infinity is infinity. Or
Maybe something else. I saw something that was surprising. I was like, oh,
no, it doesn't.
So our AK will be 1/ln k plus 1.
Okay.
Yes, AK. AK on the problem 26. It came up. You just missed it the first time around. So limit k goes to infinity, 1/ln k plus 1 is equal to 0. Good. Less than 1. So converges by a root test. Excellent. Bye.